I'm starting the first session with securing your delivery pipelines with Notary and TUF. And as you may know, Notary is a CNCF plugin or application that can be used in order to secure your pipelines. We all know some tips of container security, so this will be a security talk. You should not run your images or your containers as a root privilege. A little slide, I simplified it a little bit. So we should minimize certain attack surfaces. We should monitor and log our containers. And of course, we should only use trusted publishers. So the images we are executing, they should be trusted, and we should know what the content inside is actually, or what it is. So we are all in the field now of security, signing and verifying our container images. My name is Sebastian. I'm an engineer of cryptographic APIs, REST API especially, doing DevOps part at Securosys SA, and I was a contributor at the Docker Trust project. So containers are fast, so it gave us a little, or gives us freedomness. In terms of like a virtual machine, we can spin around, we can open ports, we can install everything on there. We are limitless, unrestricted. But the question is it therefore less secure? Is a container in privilege or basically less secure? So to go with container images, Docker images, we will have a little sample to just demonstrate how easy it actually is to play around with Docker images. We'll do an interaction here with a demo called a manifest attack. So a user, developer is requesting from a registry, public or private one, JFrog, Docker Hub, Amazon ECR, an image that is stored up there in the cloud or on your private repository, and an attacker nests in on this registry and exchanges the manifest. So he exchanges the content being delivered from the registry itself. I hope you can all see it. I will now spin up a local registry on port 5001. Then quickly double checking, is this registry actually, is it responding? Yes, we have it, or a little curl command. Yes, it is responding, that's great. For the sake of this example, we are creating, or we are storing the image. A localhost Hello World, it's a simple Nginx web application that runs certain stuff. We are building it and then we are pushing it to the registry.
Can you please
A little bit enlarge it.
sorry, because from the bottom I don't think.
Give it a sec. There is one zoom in, right?
There we go.
One more? Yeah, maybe. Let's go.
It's okay? Much better. There we go. Thank you. There we go.
Okay, perfect. So we have now created our image, build it, and we are going to execute that one. Docker run -rm, so we destroy it afterwards. It's our Nginx, runs Hello World from the container world. I now execute the so-called, or it's a little shell script, it's a manifest attack. Let's close this one. So we have, it's a shell script exchanging this, the manifest, the Docker image manifest, and then going to exchange it, especially tag it as we have defined the image before. So the Hello World tag latest image. Yeah, doing now exchanging, so this is the attacker, right? He's exchanging the image, the content of the image on the registry itself. Now we will run the Docker image again, mention echo image. It is still our localhost private registry, and it's the Hello World latest. So we are pulling the image by a tag, and we execute this image. and it should be the same image, right? But this is clearly manipulated by an attacker, the SL. Yeah, great. That's actually how easy it is for an attacker to just switch. We pulled the same image, but the image was exchanged. So security might be hard. There are, in this regard, security, it is hard to get everything right, but if you have one little weakness, your security architecture framework is just broken, right? And this is a compliance question of how are we making sure that we are running our trusted code. So maybe a QM team is verifying the image before we are doing it in production, running it in production, or we are distributing the image to customers. So how can we, where's the regulation there to sign off a release, basically? In this talk, it's not about the who, so it's not about the DevOps guy, the Kubernetes administrator that can run and execute revamp containers. It's about the what. What are we actually executing? What's the content inside the image? All right. And this one. Okay, we know the answer. We digitally sign it. So we are signing the content inside the image, and we can verify that the image wasn't tampered or anything else. So the question is, how do we sign Docker images? Maybe a quick question, who is signing Docker images currently or right now in their environments? That's a normal answer, seriously. So did this talk before, and this one or two guys really was raising his hands. There is this so-called application notary, and it's a plugin or an application done by CNCF Foundation, implemented. And what we did, we brought we tweaked this plugin to talk or integrate it into HSMs. And HSMs are hardware security modules. It's where you are storing your private keys. In order to sign content, you have to have access to these private keys, and you want to securely store them in a tamper-proof or in a hardware security module, so you have restricted access there. So that's actually what we added, or on the Notary project, we added this plugin to interact with an hardware security module, private key storage. Okay, so now we have our keys that signs content, or sign it, and we have our, in asymmetric cryptography, we have the public key, so we can verify the publisher that actually signed the content of the image, right? So we can, we are signing a Docker digest. And therefore, does anyone know what's the problem is about the yellow part here? It's a tag, right? So
digest.
Yes, it's not a digest, right? And
I can push anything to that tag that I want to.
It's not immutable, right? You can exchange the thing behind whatever it is. And what we actually want is pulling our images by a digest, because the SHA-256 sum of the content, and as of now, there's no known attack to break this hashing algorithm. So we can always verify content that has been generated or hashed. We always can verify backwards. So we pull it by digest, so we can make sure the content wasn't tampered or changed. Okay, now on the left side we have our Docker daemon, Docker engine, and on the right side our registry, a private or public one, JFrog, ECR, GCR. The daemon is requesting the registry for the digest, and the registry is requesting the registry by the tag, and the registry is returning the digest, and the daemon is then, hey, asking the registry, deliver me content for this certain digest. Registry is returning the image Docker pull, as we all know. Now the special part, or where Notary comes in, it acts as a registry. So the Notary and the registry has the same API integrations, Docker pull and all this stuff. And we are still, with the Docker daemon, we are still requesting Notary for a digest by a tag. And Notary is returning the digest, but this time it is signed. So it is signed by either Alice, Bob, or Charlie. And we know Alice, we have onboarded, we have Alice's public key to verify the signature of this image. And then we can make sure, okay, the registry, please give me content for this digest. I have proved, I have verified that that's the image I want, and the registry is returning the things. Okay, maybe a little bit more hands-on, or how do you use this in your build pipelines? Basically, these two additional commands, notation sign, your image, and private key operation. And the public key operation is notation verify. Normally, the source code gets transformed into a Docker image, and then you have you're building your image, and mostly in a larger company, or everyone should do it, you're hardening your image. You're restricting ports, you're deprivilege root users, and maybe remove some resources you don't want, or you know they are vulnerable. After the hardening process, you are publishing it to a private or a public registry, and that's where you are signing it. That means on your build server that has connection to the signing key, to the HSM in this case, you are signing your release because it's hardened, and you know, okay, that's the final image I want to execute later on in my Kubernetes Docker environment. Or for your customers, that's a possibility too. So you push it to the signed image, you push it to the registry, and once it comes into the deployment stage where you execute the Docker container, you are verifying the image before you are executing it. Questions here? Maybe some room for questions.
How do we trust Alice? How do we know?
That's
her public key?
That's you onboard on the customer or on your host. You are onboarding Alice's public key, and you speak, so to say, trust for Alice. It's a certificate that you get from the publisher of this software. So if I'm publishing new software, I'm signing it digitally. It's my duty to share with you the public key so you can verify if the content.
Out of band, another operation.
It's sorry, didn't understand. Another operation.
Yeah, it's something that happens outside.
Yes. Okay. That's the software
Okay.
delivery process then, and not the deployment process that we are discussing right now. Yeah?
So how would you integrate this verification step in, for example, a Kubernetes deployment? If my deployment says I want such and such an image, I say roll out, deploy the image from my command line. Mm-hmm. Is there a simple way of integrating, okay, verify the signature?
The admission controller. That's my answer to this. Didn't test it out. Didn't test it out, right? I saw a lot of references using Notary and Notary V1. So Notary has two versions, version 1 and version 2. I'm presenting version 2. References of using the admission controller in Kubernetes environments always use Notary V1, the version 1, but should be integratable with version 2 as well. So before your controller is taking this part. Yes?
Maybe I didn't understand completely the attack. So what does the attacker has to know in order to perform this kind of attack?
This special attack, what I just showed, they have to nest into your registry or intercept the communication stream between your registry, public, and the host, the running machine. So man-in-the-middle attacks, possible, right? Because we pulled by a tag that is immutable, I'm always confusing it, but it's changeable, right? The content behind this tag can be exchanged as you want, and the executor will not know until he executes it. Or
how likely is that this attacker could nest in, like, or how far is it?
what is your policy on your registry, right? We are using JFrog. At JFrog, our group policy has over 150 permission sets. So you want to share your software, your code. How do you share it if it's in some? It's not Docker Hub, right? It's JFrog or ECR, and you don't want to give everyone access to your resources. 150 permissions, you do things wrong if you not control it, right? If you don't control it, you will, sooner or later, there will be a flaw. And for example, a reader account has suddenly access to deploy, manage, or change your images. And that's pretty fast, right? Yeah.
Thanks.
Okay. How do we prevent that? So this is the demo of preventing our demonstration here. So we have the example. Remember, we have still the ugly image, the one with the little train. We are rebuilding our base image now. Still again. Docker build, Docker push, quickly verifying that we have the correct image, so we run it. Should be hello from container world, perfect. And now imagine you have now a clean image in your deployment pipeline on your build server, and your boss, whatever, your chef, QM team has verified that this image can go, is a production release. Before it goes or is distributed to customers, you use this notation sign. Maybe I have to first show it. I do a notation key list. So I've previously created 2 keys on the HSM. They are not extractable hardware. Created 2 keys. And I'm going to sign this image with the key Securosys sign prod down here, the second one. All right, so I have this message, successfully signed my image with this digest. Okay, I was signing it with the latest, not with the digest. I could sign it with the digest. That's this error message or warning message up here. And yeah, let's quickly inspect what we have on this image. So notation inspect. We see there is a signature attached to our digest, and here is my public key information to verify whether it's valid. So let's verify it. Successfully verified signature. It's an exit code 0, so everything went well. Let's manipulate again our image, so the fancy train. And then let's, so I've now executed the attack, and I want to verify the image now. Is it still the same? And if I didn't do something wrong, it should go into error signature failed. No signature is associated with whatever. Okay, actually, yeah, I don't have a signature associated, but if it's tampered and the signature is still associated to this image, it will not match out to in the verification scheme. So that's what I'm doing before, or the notation verify is doing the customer or in the deployment environment. It's like a SHA checksum. It's if you check up the sum of your binary file. All right. Don't know what time do we have? Is it almost over?
No one.
No worries. Cool. Docker Content Trust, yes, please.
Because you said that it was based on Notary, but then you said that you have a plugin. How do you implement that on Notation? So you have your plugin for the Securosys?
Yes, yes.
So it's already built in the same CLI?
It's built into the same CLI, so the commands stay the same. Notation, key add, key list, and all this stuff. You won't see any difference except on a installation part where you configure your connection details, of course, to the REST API or the HSM itself, right? And it's written in Go, the plugin, so yeah, and binary is probably available, so to say. Or you can build it by yourself, if you don't trust. Okay, another question?
So wait, actually I have a question. So actually the assumption here that we're making the request from the Docker host using HTTP.
Mm-hmm.
Right?
Man in the middle.
We're not mentioning SSH or HTTPS request. So I'm assuming that you're talking about the first risk, the manifest hacking, because we are using an insecure protocol at the beginning of the process. We're using HTTP. Is that right?
Okay, for manifest exchange, how can I put that?
Slide
As said, you are mentioning it's in the transport. The attack happens during transport, right? We are not encrypting our traffic or our HTTP session. So we are not using TLS, SSL TLS. But what happens if an attacker plugs in or is on top or inside your registry? And how can you verify whether your image is malformatted by this attacker? Right? It's not only during transport this attack. It's also if someone exchanges your binaries on your distribution pipelines to your customers. There are a lot more image attacks than only during transport and during registry or provisioning of your image, right? Hope I could answer this. So, Docker Content Trust, it was the V1, and you mentioned it was a talk 3 years ago. It was the version 1 of Notation, and it's a CNCF project as well. The problem about Docker Content Trust, the first version, is that we have only a binary operation. So we only can restrict to sign all our images in the registry or on our host, or none. So there is no fine granular access and policy control what images I want to have verified. For example, yeah, this one, 2 images. The first image is for a customer. The second image is only a testing image for your DevOps guy who want to test out something. He doesn't need to verify the execution of the image because he just wants to test out. Docker Content Trust had this issue. It was a binary notification set by an environment variable on your host. The second problem with Docker Content Trust is your signature is not attached to an image. Sorry, the signature is attached, but because registries didn't follow a standard, the OCI standard for registries, signature was simply lost upon pulling and pushing to unsupported OCI registries. That's a huge problem, so you sign for nothing, right? And again, who else do we trust? Can I find control and access control images and verifiers of my image? Okay, maybe this is a branding, nobody likes it. Securosys, as said, HSM provider, we are manufacturing boxes that stores private keys, so the vault of your private keys, the most sensitive material we have. and therefore these keys, they cannot be extracted. So you cannot export them or rip them out. So you have different controls of shutting down the key usage, in case your private key or your access credentials to the HSM has been hacked. I mean, it's possible someone nests in, or just gets access credentials, the JWT token, to your HSM or to your private key. And how do you treat that, right? You want to have quickly shut down this connection so the key cannot be used furthermore. If your private key in PEM format got leaked, or it's a file, right? It's a file that can be distributed, and with the file you cannot restrict. You can have a public verification server, and then you can blacklist the public key, like CRL or OCSP is doing it in HTTP. Further, there is this multi-authorization framework. Oh no, let's go for the notation plugin does prevent several attacks: manifest attacks, layer attacks, man in the middle, all the secure vulnerabilities we know in Docker container distribution. And with this plugin, especially it's another plugin, we support Docker encryption. It is called Scopio, so you can encrypt your sensitive content and push it to the registry. Easy CI/CD integration, you have notation sign and verify that interacts seamlessly. It's a CLI tool application. And with Securosys, you have multi-authorization framework. It's an approval framework, so your product manager has to sign off or has to give an approval in order to sign off this release. And with the smart key attributes multi-authorization framework, you can have this kind of additional protection. Lastly, my final words. Major release was of this notation, so of the notation plugin from CNCF was August the 22nd, launched in or the year 2023. Yes, and that's it. Thank you very much for listening.